difference between two pitches is called an interval. The smallest musical interval is the unison, which is two sounds at the same frequency. Frequency is the number of vibration cycles per second of a wave, and it is described in hertz. 440 hertz is the frequency of the A that is sounded by the oboist to tune an orchestra, for example. A perfect unison is when two instruments, the violin and the oboe, for example, sound an A at 440 hertz. If the oboe plays A at 440 hertz and the violin plays A at 441 hertz, the unison would not be perfect, and it would be said to be out of tune. However, pitches that are in tune with one another can produce sympathetic resonance. Observe how when I play on the violin, a stopped pitch, A, that is in tune with the A string is excited so that it rings sympathetically. Can you hear the after ring of the open A string? Our perceptions of intonation, consonance, and dissonance, therefore, have a mathematical and scientific basis. When something is said to be in tune or consonant, the relationship between their vibration rates of one sound and another are in sync with one another. In other words, concordant. When something is said to be out of tune or dissonant, the vibration rates of one sound and another are out of sync with one another, in other words, discordant. The closer the frequencies are without matching, the more discordant they are, and that discord can produce the illusion of beating due to the mathematical differences produced by their conflicting frequencies. Violinists are familiar with this phenomenon when tuning their strings. When one string is out of tune with another, it seems to beat, and the beats speed up as one approaches a perfect intonation, until the beats disappear. When the strings are exactly in tune with one another, the beats will disappear. The beats have disappeared there. I'm going to detune the strings now to show you what happens. Notice the beating as the pitches approached perfect